If you are new, subscribe the channel and press the bell icon to receive regular notifications about my videos regarding job updates or computer science topic that I make.
Hello guys, I am Parinta and welcome back to my channel to polish your CHC concepts with me. So let's get started. Our today's video is regarding one of the important topics of compiler design, that is syntax directed translation, which is commonly known as SDT. Fine. This topic is very important to know because once you understand the concept of SDT, you will actually get to know that how the compiler works. This is actually a small topic, a simple topic, but many people are not aware of it. But you should be knowing this topic because it tells us very important things about how the compiler is working. And apart from that, it is actually a very important topic in terms of academics also, or in terms of competitive exams also. So let's see what actually SDT is. SDT, that is syntax directed translation, we can say that it is nothing but it is equal to the grammar that is given plus semantic rules. I hope you are knowing the basics about compiler design. You must be knowing what is grammar. We have already seen in our previous many videos. I have shown you the details and I have also shown you the examples of which types of grammar are there, how the grammars are working and all those things, right? So we know that we are having grammars in compiler design that compiler understands. Along with the grammar, if we combine the semantic rules, we are getting this togetherly forms SDT. Now what do we mean by semantic rules? Semantic rules are nothing but informal notation. Okay, with the help of example we will see that, you will get a better idea. Now if I talk about definition, you can say that along with the grammar we are giving semantic actions also, such that along with the parsing task, some other tasks can also be done in parallel, like code generation, intermediate code generation, expression evaluation, etc. Now what do we mean by that? We already know what the grammar is, right? For example, here you can see E gives E plus T or T, T gives T star F or F, and F gives num. You must be aware, we have already seen many examples that this formation that is shown here, it is actually known as grammar. Now what is the main use of this grammar? With the help of this grammar we will be able to know that how or which are the strings that the compiler is parsing. So basically this grammar is used to parse the string. But what happens that if we are giving, see, these are what we are known as semantic rules. These are the things that are semantic rules or informal notation. So what is the use of this informal notation? That with the help of only grammar we will be able to know about the parsing way or the parsing style, right? But if we are giving this semantic rules along with this grammar, this semantic rule suggests other tasks that are done in parallel by the compiler, because at a time it is not like that compiler is doing only one task at a time, right? So with the help of grammar, no doubt it will be parsing the string, but along with it, with the help of the semantic rules, the compiler are doing, if we are giving the semantic rules to the compiler will be doing other tasks in parallel, like intermediate code generation, expression evaluation. All those important tasks can be done in parallel, right? And if we are giving this grammar along with the semantic rules, they both are combiningly known as SDT, that is syntax directed translation. So simply we can say that along with the productions, we are having the actions that have to be performed, right? Now let's see with the help of example. Here one SDT is given. SDT is given means my grammar is given and along with the semantic rules are given. Here I have taken a simple example so that it will be easier for you to understand how the semantic rules are there. See, here E gives E plus T. Along with this, the rule given is E dot value this is equal to, that means here by the semantic rules we are telling that what this production exactly mean. So E gives E plus T. Its semantic rule is E dot value means what this production will do, E dot value equal to E dot value plus T dot value. Similarly, E gives T, what it will do, E dot value equal to T dot value. T gives T star F, that means T dot value equal to T dot value cross F dot value. And T gives F means its semantic rule is t dot value equal to f dot value, and f gives num is f dot value equal to num dot value. So this is the grammar, and these are the semantic rules corresponding to this particular grammar. And now which type of questions are given? For example, they have given you this SDT and they are giving you this expression, that for example this is the expression. You have to apply this expression on this given SDT, and ultimately you have to show that what is the answer. See, this SDT, if you see this minutely, you can say that this expression is the expression of equation evolution of any equation, right? So this is this SDT will be given, this expression will be given, and they will tell you that with the help of this SDT, evaluate this expression and let us know the correct result, correct answer. So how we will do it? So for SDT, I have written the rules for you here. See, these are the main 3 rules or 3 steps that you have to keep in mind while solving any SDT. Again, this is the example, this is the question. Fine, you will be given like this SDT, you will be given one expression, and with the help of this SDT, you have to evaluate this expression. So which is the what are the main steps to evaluate such SDT? The first step is to generate parse tree from the given grammar. Grammar is given, we have to generate parse tree. Second, parse the tree. How? Left to right and top to bottom. Fine, I will show you how to do that. And the step 3, the ultimate step is, whenever there is a, now the second step is we have to parse, but how? Top to bottom and left to right. Okay, like that we will parse it. And while parsing, whenever there is a reduction, we have to go to the production and carry out the action. This is the important task in case of SDT, that whenever there is a reduction means whenever we are going from RHS to LHS, that is known as reduction. Now whenever there is a reduction, we have to go to the production, the given production in the grammar, and we have to carry out the corresponding action. Which action? The corresponding semantic rule that is given, right? You may understand the step, or if you find it quite confusing, then with the help of example, you will really get a clear idea. Fine, you just need to remember these steps. Okay, now let's start. What is the step number 1? We have to generate parse tree from the given grammar. Now as I told, this is the example. This is the example of the grammar that is given to us. So with the help of this example, we have to generate the parse tree. So that is very simple. How we are generating the parse tree? We are always starting with the starting symbol. Here what is the starting symbol given to us? Capital E. So we will start with capital E. Now don't see anything else. Don't see the digits. Whatever I am saying, follow the steps and you will get it. The first step is we have to generate the parse tree from the grammar. Now for generating the parse tree, we will start with the starting symbol. Here the starting symbol is capital E, so we will start with the capital E. We are starting with this capital E. Now capital E is giving E plus T, so we are expanding it and E gives E plus T. Now again E gives what? T. So E gives T, T gives F, and F gives num. See, this is a simple step how to generate tree. You must be knowing that. So with the help of this grammar, we are generating this tree. Because in this video, our motive is not to learn how to generate a tree. We will just see how SDT works. Fine. So we will generate a tree, and this is actually a very common grammar that we are using mostly in all the examples. So you must be aware of this tree also. Fine. So with the help of given grammar, we will generate this tree. So first step is over, that we have generated this parse tree from the given grammar. Now what is the second step? We have to parse the tree from left to right and top to bottom. Fine, we will do that. And the third step is whenever there is a reduction, we have to go to the production and carry out the action. Now this is an important task. I will show you how to do it. We have generated the tree, right? Now what we have to do? We have to parse the tree, and whenever there is a reduction, we have to do the action. Okay, now let's start parsing the tree. Here E gives, we are parsing, how we are parsing? Top to bottom and left to right, means like this, top to bottom. This is the way we will parse it, and left to right. Okay, now let's start parsing. E gives capital E. Okay, now what do you mean by reduction? Whenever we are going from LHS to RHS, see, this is grammar, right? From the grammar, it is you can say that these are our LHS parts, and this side, from in the right side, these are our RHS, right hand side part. These three are LHS, these three are RHS. Now what the rule says, whenever we are expanding from LHS to RHS, that is not reduction, but whenever we are doing the opposite, you are getting, whenever we are getting E from E, if I am getting from E plus T, I am getting from E T, whenever I am getting from LHS to RHS, that is not reduction, but the opposite, whenever I am getting RHS from RHS, whenever I am getting LHS, means whenever from num I am getting F, or from F I am getting T, whenever in the opposite direction I am getting like this is known as reduction. Means our RHS is reduced to our LHS. You can remember it like that. So whenever our RHS in the given grammar, whenever our RHS is reduced to LHS, that is known as reduction move. And whenever there is a reduction, whenever we come across any reduction, we have to perform the corresponding action. That is what SDT says. Fine. Okay, now let's see. We are passing from here. Now E gives E plus T. E gives E plus T. So this is left to right. We don't have to do anything. That is not reduction. E gives T. Again E gives T. That is not reduction. T gives F. T gives F. It is not reduction. F gives num. Again F gives num. That is not reduction. So we have completed up to here. See, we are parsing like this. We have completed up to here. Now again we have to go right to left. We have to go left to right, right? So we have come up to this. Now here what is F is giving, see, sorry, num is from this side we are checking. Now we have reached up to here. Up to here there is, up to this point we have got no reduction yet. Now we are coming here up to here, what we are getting, that num is giving F. Num gives F. So yes, this is reduction, that my RHS is reduced to LHS. Num is reduced to F. So here it is reduction. Now we have to see the corresponding action. Num gives F. So the corresponding action is F dot value. Initially, after making the tree, we have to see that what is the expression that is given to us. In this case, the expression given to us is 2 plus 3 star F. So what we will do after making the whole tree, we will get tree like this. What we will do, we will assign the numbers 2 plus 3 star F. So we will assign 2 plus 3 star F. So basically we have assigned this num as 2, this num as 3, this num as 4. Got it? Because this is the expression that is given to us. If the expression is different, we will assign it differently, right? So we have already assigned this num as 2, this num as 3 and this num as 4. Well, now where were we? We were reducing it. So num is reduced to F, num is reduced to F. This is reduction. So the corresponding action we have to do is F dot value is equal to num dot value. Now already we know that num dot value is given to us 2. We have already assigned it. These three are the things that we have assigned as per the expression given to us. Now here what my action says, that F dot value is equal to num dot value. So num dot value is 2. So now my this F dot value will become 2. Got it? Okay. Now we will proceed further. T, F gives T. Now F gives T. This is again RHS is reduced to LHS. You are getting the difference, right? Here again LHS is reduced to RHS. That means again this is my reduction move. So I have to see the action. The action is T dot value equal to F dot value. Now T dot value will be equal to what? F dot value. F dot value we have already written it as 2. So again this T will also become 2. Fine, this T will also become 2. Now again we will proceed further. What we got? T gives E. Now T gives E is again reduction, and what is the action? E dot value equal to T dot value. Now E dot value equal to T dot value. So this T will also become plus, will also become 2. Now again here we are going no reduction move. Here T gives T star F. T gives T star F. This is not reduction, this is forward. T gives F. T gives F is again not reduction. F gives num. This is again not reduction because this is LHS to RHS. Okay, so we don't need to do anything. We don't need to do anything unless it is reduction. Fine. Now again we are proceeding. Num is giving F. This is reduction. So F dot value equal to num dot value. So num is, in this case, num is 3. So this F will also get the value 3. Now again we are forwarding. F gives T. F gives T is again reduction. T dot value equal to F dot value. So this T will get the value of F, that is again equal to 3. Now again we will proceed to parse. No reduction. F gives num. F gives num is LHS to RHS. So it is not reduction. Again we will move forward. Here num gives F. Yes, num gives F is again reduction because RHS to LHS. So we will get what? F dot value equal to num dot value. In this case my value of num is 4. So I will assign 4 to this F. Alright, now again we are proceeding further. Now here, after proceeding up to this, what I am getting? T star F is reduced to T. T star F is reduced to T. Yes, it is RHS to LHS. So yes, it is reduction. So what is the corresponding action that I have to perform? That T dot value equal to T dot value star F dot value. So T dot value is 3. Okay, T dot value, the new T dot value will be equal to what? New T dot value will be equal to what? T dot value star F dot value. T dot value here is 3 star F dot value. F dot value here is 4. So I am getting 12. 3 cross 4 will be 12. That means this T dot value, the new T will get the value 12. Right? Okay. Now we are again proceeding further. And this is again E plus T gives E. Let's search it. Here it is. E plus T gives E. So again here it is RHS to LHS. That means it is a reduction move. That E plus T is reduced to E. So what is the action? That E dot value, the new E dot value will be equal to what? E dot value plus T dot value. This E dot value plus this T dot value. So 2 plus 12 we will get 14. So this E will be assigned 14. Now this is the starting symbol. Our ultimate symbol, the value we got is 14. That means we can say that whatever the expression was, the value of that expression, the ultimate result we got is 14. Fine. See, this is simple one. So you can verify the answer also. 3 into 4 is 12 and plus 2. So 2 plus 2, 12, we will get 14 also. So you can verify the answer. But this is the way our SDT works and this is the way you should solve. If there is any complex question also, if there is any complex question that is given to you. But if you know these steps, if you are performing these steps step by step, if you are going, you will definitely get the correct answer. Fine. So guys, that's all about SDT. If you liked my video, if you think that my video was helpful, please share and subscribe the channel and let me know that you liked it by leaving your like and comment in this video. Thank you so much.